Good morning, students. This is part 2. In this part, I am going to discuss about the reversible isothermal expansion process. This is process 1 to 2. This is process 1 to 2. In this process, the gas gets expanded reversibly as well as isothermally. This is part 2. Okay, ma? Okay. In this part, this is Carnot engine. In this engine, 1 mole of an ideal gas is trapped. Now the gas is allowed to expand. Gas is allowed to expand. Allowed to expand. Allowed to expand. Listen carefully. During the expansion, the gas utilizes certain amount of internal energy to lift the piston in upward direction. The gas utilizes certain amount of its internal energy to lift the piston in the upward direction. Due to decrease in internal energy, the temperature goes to decrease. Temperature gets decreased due to expansion process. Temperature from T1 to T2. Temperature gets decreased. In order to avoid the decrease in temperature, the cylinder head is bring to contact in a source. That means high thermal reservoir. The gas is allowed to expand. During the expansion, the temperature of gas gets decreased. To avoid the decrease in temperature, the piston cylinder arrangement, cylinder head is made a contact with a source, what you call hot thermal reservoir. Its temperature is TH. Energy gets continuously transferred from source to engine in order to avoid the decrease in temperature. Hence, the temperature of gas is maintained as constant. The level is TH. Temperature is constant. Since temperature of the gas is constant, it is isothermal. Now the gas expanded isothermally. What about reversibly? Reversibly means what is the amount of heat gets exchanged from source to engine. The amount of heat exchanged from source to engine, that means QH. Equal amount of heat is utilized for the expansion work. Equal amount of heat is utilized for the expansion process. Hence, we may say that gas gets expanded isothermally and reversibly. Clear? Isothermally means during the expansion process, the temperature goes to decrease. Consequently, internal energy goes to decrease. To avoid the decrease in temperature, certain amount of heat gets transferred from source to engine by bringing a thermal contact. The cylinder head is made a contact with the source. Heat gets continuously transferred to the engine in order to avoid the decrease in temperature, in order to avoid the shortfall in temperature. Hence, the process is constant temperature. That means isothermal. What about reversible? The amount of heat transferred from source to engine is completely utilized for the expansion work. Hence, the gas expanded isothermally and reversibly. Is it clear now? Okay. Since temperature is constant, internal energy of the gas gets constant. Internal energy U is constant. Since internal energy is constant, changes in internal energy is equal to 0. Okay. Changes in internal energy will be 0. Now the PV diagram. This is volume, this is pressure. From position 1 to position 2. Okay, wow? Pressure gets decreased due to expansion. Subsequently, volume gets increased. This is the first position 1 to position 2 or process 1 to 2. In this process, internal energy is constant. Changes in internal energy is equal to 0. Clear? Right. Now I am going to calculate the amount of work done. Amount of work done for the expansion process under isothermal reversible condition. Amount of work done. Okay. Using first law of thermodynamics. Using first law of thermodynamics. First law of thermodynamics says that changes in internal energy dU is equal to dQ minus dW. Changes in internal energy becomes 0. Hence, this equation is dQ is equal to dW. We pretty well know that W is equal to PdV. Hence, integral PdV. Clear? Integral PdV. Okay. Q1 to 2 or QH is equal to W1 to 2 is equal to integral V1 to V2 PdV. PdV. Since it is an ideal gas, I am going to replace P instead of RT by V. Instead of P, I am going to write RT by V. Therefore, integral V1 to V2 RT 1 by V into dV. Clear? So, QH, amount of heat transferred, it is completely in place for expansion process W1 to 2 is equal to RT ln V2 by V1. This is the equation we are need to find the efficiency of the heat engine. This is part 2. In this part, we are going to discuss about the expansion under isothermal and reversible condition. Clear? This is the final equation. Isothermal means temperature is constant by continuous supply of heat from source to engine. Due to continuous transformation, the temperature of gas is maintained as constant. Hence, there is no changes in internal energy. Since there is no changes in internal energy, it is constant. dU is equal to 0. From first law of thermodynamics, it is possible to find out the amount of work done. Amount of heat transferred is exactly equal to amount of work done. Hence, it is a reversible process. Okay. Okay. Next part is part 3. That is isothermal, reversible, adiabatic expansion process. Students, please continue your lesson in the next part also. Thank you.